So this is lesson 1.5, measurement systems, and our first objective here is to state the different measurement systems used in chemistry.
And we're going to state the different prefixes used in the metric system. So you're going to want to read chapter 2, section 2.2, which begins on page 27 in your reading packet to go along with the information we present to you. All right, so as soon as people got organized into societies, they found that it was important to have measurement systems so you could sell things and buy things and know how much you were getting. So standardized measurements, initially were like, the width of your thumb was an inch, or the distance from your nose to a man's tip of his fingers was a yard, or the length of his foot was a foot. And then that helped, but then eventually it became even more standardized than that. They would use, the length of the king's foot or whatever as a foot.
Which of course changes every king.
Yeah, and so as time went on, the measurement systems became more and more standardized. And what do we mean by standardized? Well, that everyone agrees what size the measurement should be. So, and we have a system today in place where the measurements are highly standardized, and anyone in the world can measure it. And if they say it's a certain number of meters or a certain number of liters, someone else could reproduce that exact amount somewhere else just from the measurement. So the standard measurements that we use in science include mass, volume, length, and temperature, and time, which we kind of left off this, but time would be on that list too. And then there's many, many other specialized or derived units that come from combinations of those things, or in some cases like there are their own unique type of measurement. Things like density and pH and force and pressure are units that have their place as well in depending on what you're trying to measure. So what is this standardized worldwide system that we use now, Mr. Hunter?
Well, that'll be the metric system. As you just said, it is the international decimal-based system. So it's based on a set of 10. It goes up by tens. It makes life easy, unlike our system where, you have 12 inches in a foot, 5,280 feet in a mile, et cetera, et cetera.
All sorts of strange equivalences. But the metric system, also referred to as SI, is used in all official scientific measurements and really in all but a few countries, and it just so happens that the United States is one of the handful of countries that hold out with their antiquated measurement systems. But so what are the base units in the SI, or the international system?
For length, we have the meter. It's represented with M.
Mass would be measured in the base unit of grams, with a small g being the abbreviation.
For Celsius, it is degrees, or for temperature, it is degrees Celsius, or the Kelvin scale, which is just a capitalized K.
No degree symbol in Kelvin. And then volume would be liters, which is an L. And you notice that most of the other metric units are lowercase, but for liter, we've changed it over to a capital L just to avoid confusion, because lowercase L's look a whole lot like number ones.
Yes.
So we use capital L for liter. So the standard or international system prefixes and meanings, because we often have to measure things that are larger than a meter or smaller than a liter, we can modify the meaning of those units by sticking a prefix on the front. And I don't think I'm telling you things that you didn't probably already know. So certainly prefixes like centi and milli you've encountered already.
And mega, because you have megabytes and you have kilobytes.
Right. So going big to small, this is not all of the SI prefixes, but these are ones that probably anyone, reasonably well-educated person should know. And the ones that have the double asterisks here are ones that you, for our chemistry course, must know.
Mm-hmm.
Okay, so we'll just go, this is on a page in your packet. Since we didn't send the packet to the print shop yet when we're recording this, I can't tell you the exact page, but find this page in your packet, and we'll just run down through them really quickly. All
right. So the first one is tera. It is abbreviated with a capital T. It is a trillion. That's 10 to the 12th. And you can see on the right here, these are your equivalence relationships that will come useful.
When we start converting units, that's going to be highly useful, right? Then we've got giga. And again, you've probably heard those already in computer terms. We talked about that. You're going to have a terabyte hard drive or a 500 gigabyte hard drive. Capital G is giga. that's billion. So it's still a big number, but it's 1,000 times smaller than a trillion.
100 times. 3 zeros. Oh, because it would be 1,000. You're right.
Okay.
All right, mega. Sorry, you have to admit when you're wrong. See.
Okay.
Mega is big M. That's a million, and it is 1,000 times. Yes.
1,000 times smaller than a billion.
All right.
And then now we're going to units that are smaller than the base unit,
Of 1.
which would be 1. So centi, we can stick that on the front of centiliter, centigram. We abbreviate it with a small c. That means 1/100th as big as the base unit.
0.01. So milla is another one you have to know. So mega, centa, and milli are the ones you have to know so far. Milli is a small m, and it is a thousandth. That's 0.001.
Okay, you notice that we stuck with the exponential notation here just because it saves writing a lot of
Yes.
zeros. Okay. Micro is the next one as we're on our downward trend. This is the only one that doesn't have a sort of normal English letter. That's actually a Greek letter.
Called a
It's
mu.
Greek letter mu. And you can write it like a lowercase u with an extra tail hanging off the front of it.
Yep.
Okay, and it means a millionth. So a micrometer is a millionth of a meter.
0.00001. I think there's 5 zeros and a 1 there.
I'm going to say you're right because I didn't count them.
And I think next is nano. We talk about nanotechnologies now, especially in our modern technology. It's a big field. That is a billionth of 1, so it is tiny. That is smaller than cells.
So if you want to talk about sizes of atoms and molecules, often this is the unit we would use as how many nanometers across a bond is, or
that's
or
the size of
a
an atom.
molecule. And then stepping down even further, when you start to talk about parts inside of an atom, you need some even smaller units. Pico is the next one as we go down, lowercase p. That means a trillionth of the base unit. So a picosecond is a trillionth of a second.
And then lastly is our femto with an F, and it's 1/4 of. And like we said, we kind of went through this kind of slow, but the 6 or is it 5? 5 you have to know are very important to learn, so please learn them and refer to this in the future. All right, so in our post-video questions this time, we would like you to write each measurement with the correct unit abbreviation. So 10 millimeters, 127 Kelvin, 6/10 of a kilogram. Please abbreviate with the correct unit. And in the second part, what prefix is this? So for 1,000 or times 1,000, they want to know what prefix that would be.
And we'll just do that as an example. That would be the prefix kilo. It means times 1,000. Okay, now even though we use exponents on the other one, we switched over to decimal on you. We're tricky like that.
Which is why I did mention 0.00 something when we were talking about a lot of those to give you that hint. So finish these up, and we'll see you tomorrow.